All right, when you're looking to classify these shapes, specifically these quadrilaterals, if we have a parallelogram, there are several different ways we can classify them. So we could classify them by the opposite sides being congruent. We could classify them if both pairs of opposite sides are parallel. And we could see if the diagonals bisect each other. So to see if those opposite sides are parallel, here, I'll do that. To see if those opposite sides are parallel, what could you use? What do you know when we're using coordinates? If two lines are parallel, they have the same what? Same slope. So we could use slope to determine if lines are parallel. Okay. Now, how could we determine that the opposite sides are congruent? So the lengths are the same. How could we use that? Okay, you could count the boxes, or we could use distance formula or Pythagorean theorem to determine if lines are congruent. All right, so now if the diagonals bisect each other, we could use midpoint. Because if two lines have the same middle point and they intersect on that, that would mean they cut each other in half at the same point. Okay? So now as we go down, and we look at rectangle. It has all the properties of a parallelogram, but here is what is unique. The sides are perpendicular, and the diagonals are equal in length. So what could you use to determine if sides are perpendicular? They intersect at a right angle. Okay, in class we went over how to determine if slopes were perpendicular. So slope could determine both if lines are parallel or perpendicular. And as a reminder, if lines are perpendicular, the slopes are opposite reciprocals. So a base example would be if the slope is a over b, the opposite reciprocal slope would be negative b over a. If we put actual numbers into that, let's say a is 2 and b is 3. What's the opposite reciprocal slope? Negative 3 over 2. So if you had these slopes, those lines would form a right angle. Okay, all right, so now if we go on to a rhombus, still has all the properties of a parallelogram. And here's what's special here. All four sides are congruent. And the diagonals are perpendicular. So once again, distance formula and using slope. All right, square is what's really special. Square has all of these properties, the properties of a parallelogram, a rectangle, and a rhombus. So with the square, you'd need to check that all those form right angles, all the lines form right angles, and that each of these lines are what? Are congruent, yes, equal. All right, trapezoid, exactly one pair of parallel opposite sides. So I'd have to look at the slope of the bases. It's not going up, so there is no slope, but I mean like if you had it on a coordinate plane where it's tilted like that. Okay. Now with the kite, we have two pairs of congruent adjacent sides. So that means that these sides are congruent. And these sides are congruent. And the diagonals are perpendicular. So they form a right angle. The diagonals do. So once again, you can use slope and distance formula. Okay, so what I'm going to use now, occasionally there are shapes that are triangles, obviously. So if we had triangles, let's flip this over and talk about a little bit about the triangles. Let's say I have an isosceles triangle. Do you remember what an isosceles triangle is? No, an isosceles triangle has two congruent sides. So two sides of equal length. A scalene triangle has no equal sides. No equal, congruent. I'm using those terms interchangeably even though they're slightly different. An equilateral triangle, it's in the name. Can you tell what it's going to be? Has three congruent sides. And then we have a right triangle. And you guys know what a right triangle is, right? A triangle with a right angle. And for now, that's as far as we're going to classify using triangles. Okay? Okay. So now, again, These are our tools: slope, distance formula, and midpoint theorem. These two are the most common by far. And then we have